All right, so our lesson today is going to be the rule of a quadratic mapping. The rule of quadratic mappings. Okay, all right, yes. Previously, we have looked at the rule of linear mapping, the rule of exponential mapping. Okay, all right. So this time we are looking at what quadratic mappings are, how to find the rule. Okay, we'll not waste time. Let's quickly look at what we mean by quadratic mapping. In this case, we are saying that quadratic mapping is a mapping in which the first difference of consecutive elements of the codomain is not common or constant, but the second set of consecutive elements of the codomain is constant. Yes, so we are going to look at when we see the first difference of the consecutive elements of the codomain is not common or constant, but the second set is what? Constant. We are going to look at that. So when you realize that such a mapping has these qualities, then we classify those mappings as what? Quadratic. And as a matter of urgency, we are going to use the rule giving us what? Y is equal to ax squared plus bx plus c. So looking at this, you can see that this is the general rule. This is the general formula, or the formula of what? A quadratic equation. Yes, that's what we are saying. It's a quadratic mapping. Yes, because we have y here, and this is what? A relation. All right. So the a and b and the c you see here, they are what? Constants. They are values that we are going to look out for. After getting them, then we substitute them back to the general rule, and that gives us the rule of the quadratic mapping. Okay, but let's look at how we can find the rule of the quadratic mapping. So we are saying that to find or determine the rule of the quadratic mapping, what we will do is that we will choose three different pairs of elements from the domain and the codomain. In that case, we are picking x value, y value, that is x 0, y 0, x1, y1, x2, y2. So these are the pairs, the three pairs of elements from the domain and the codomain. So these are the values that we are going to pick and substitute into this equation, which will help us find the values of A, B, and C. Okay, so without wasting much time, let's take a question, or let's take an example and look at how we can find such rules. All right, okay. Okay, so this is the example we are going to look at. We have to find the rule of this given mapping. Okay, so as I always say, that when the question is given to you, all that you do is check whether it is a linear mapping. If it is not, then you check whether it is exponential mapping. If it is not, then you check whether it is quadratic mapping. Even if you check and it is not quadratic mapping, there are some mappings that will neither be linear, exponential, or quadratic. And for such mappings, we can only just find the rule by just glancing through. Okay, yes, we just do inspection. It's just the rule can just be found by inspection. We can just look at it and tell the rule. Yes, such mappings, they are neither linear, exponential, or quadratic. All right, good. But for now, we are looking at the main three mappings, that is the linear, quadratic, and exponential. All right, so this question, you ask yourself whether it is linear or quadratic or exponential. So first of all, let's test for linearity, whether you get a common difference on the domain and common difference on the codomain. So if I'm finding the difference, let me check. You can see that for the domain part, 2 minus 1 gives me 1, which is the same as 3 minus 2 gives me 1, which is also the same as 4 minus 3, which is 1, also equal to what? 5 minus 4 equal to 1. So you realize that for the domain, we have common difference as what? 1. Let's also check for the codomain, where we can subtract 3 from 8 and get what? 5. Is it the same as when we subtract 8 from 15? You realize that we are getting what? 7. This is not the same. And also, is it the same as when we subtract 15 from 24, which gives us what? 9, which is not also the same. Okay, which is not the same. So if we should also subtract 24 from 35, you realize that this one too, we are getting what? 11. Okay, which is not also what? The same. So once you realize that it's not the same, then linearity doesn't work here. There's no linear mapping here. Then we check for what we call it, exponential. And exponential too, we say that when we have common ratio of the codomain, then we can say it's exponential. So let's test for ratio, common ratio. So it means that if I should divide 8 by 3, is it the same as when I divide 15 by 8? Is it also the same as when I divide 24 by what? 15? Or the same as when I divide 35 by 24? You realize that they are not the same. Okay, cool. So we are not getting common ratio here. Since we are not getting common ratio or constant ratio here, then we test for quadratic mapping. And what did we say quadratic mapping as? We are saying that when the first difference of the consecutive numbers of the codomain is not the same, but the second set is the same. So let's test for the difference of the first consecutive. So the first consecutive we were talking about, this is how we do it. So the first place, I'm going to find the difference of the consecutive numbers on the codomain. So I'll write 8 minus 3, which gives me 5, which is supposed to be 15 minus 8, which will give me 7. And then we have what? 24 minus 15, which also gives me what? 9. And the last part is what? 35 minus 24, which gives 11. So you realize that these are not the same. The difference are not the same. In this case, we can't say this is equal to this. We can't say this is equal to this. Have you gotten that? Good. So this is the first set of the difference, which is not what? We don't have common difference. So the second set of the consecutive element on the codomain we are talking about are the answers we got. Okay, the difference we got for each of them. These are what we are going to find their difference as well. So it means I'm going to subtract 5 from 7. I'll subtract 7 from 9. I'll subtract 9 from 11 and see whether I will get what common difference. So let's try it and see. If that is the case, then 7 minus 5. Is it going to give me what? 2. Is it the same as when I subtract 7 from 9? It's also giving me what? 2. Is it the same as when I subtract 9 from 11? Yes, this one is also giving me 2. So you realize that the second difference give me the same what? The same difference, the same answer. So I've gotten a common difference. Once you get a common difference for the second set, then this suggests that the mapping is what quadratic, and that you can use the general formula given. All right, in that case, how do we find the rule of quadratic mapping? And this quadratic mapping is given by this rule, which is y is equal to ax squared plus bx plus c. All right, so we are only looking for values of a, b, and c, then we substitute. But how do we get that? In a previous explanation, we said that you pick 3 pairs of elements from both codomain and the domain, and then you substitute the value. So let's look at how we are going to pick those pairs. Okay, in that case, we use this x nor, and then x, we use x nor, y nor, and then we have x1, y1, and what? x2, y2. So what are these x nor, x, y, and all that? These are the elements we can find here. So when we say x nor, we are talking about element. We can choose one as our x what? Nor. So I will pick 1 for x nor, then I'll pick its corresponding value on the y-axis, which is what? 3. Then I will go here. It means if I move from x nor, then I'm moving to what? x1. That means if I picked 1, then the next number on the x-axis or the domain is what? 2. So this x nor, y nor, y1, and all that, they are the element of the domain. All the x, x, x you see here are the element of the domain, and all the y's are the element of the codomain. All right, great. So I will pick my next value, which is what? 2 for x1, and its corresponding value is what? 8. Then I will pick my next value, which is 3 for x2, and then I will pick its corresponding, which is 15 for y2. Great. So these are the values that we are going to substitute into the general rule. Then we are going to get 3 different equations. Then we solve it what? Simultaneously. Okay, after getting these 2 or these 3 equations, we are going to solve them simultaneously. All right, okay, so let's see how we can get these 3 equations. Okay, all right. So let's look at how we can substitute these values. So it means that when x is 1, y is what? 3. So I will do that. Okay, yes. So if that's the case, then I will have my 3, which is equal to a, then I'll have 1, which is x is exponent 2, plus my b, which is what? 1, because we are saying that the x is 1. Then I can have 3 is equal to a plus b plus c. Then I can call this what? Equation 1. Have you gotten that? Good. So I substituted these values. I'm going to substitute the 2 and the 8. So it means when x is 2, y is 8. Then I can write 8 is equal to a, then we have 2 squared plus b, 2 here, plus what? C, which gives me a is 8 is equal to 4a plus 2b plus c, and I can call this also equation 2. Okay, let's left with the last pair of elements, which is 15 is equal to A, then I have 3 exponent 2 plus B, then multiplying 3 plus my C, which gives me 15 is equal to 9A plus 3B plus C. So I can have another equation, which is equation 3. Alright, good. So this is my third equation. So once we have these 3 equations, then we can further solve them. We are going to solve these equations simultaneously. Alright, good. So if I have this, then I can subtract equation 1 from equation 2. Okay, good. So if that is the case, then I can write 8 minus 3. So I'm only subtracting corresponding values, okay, which is equal to 4a minus a plus 2b minus b is equal to c minus c. Okay, so I'll get 5 is equal to 3a plus b, because the c, so this is plus c. Okay, the c will just cancel out. Okay, then I will have another equation called equation 4. Okay, I can also subtract equation 2 from equation 3. I can subtract equation 2 from equation 3. If that is the case, this is equation 3 and equation 2. Then I'm subtracting corresponding entities. So 15 minus 8 is equal to 9a minus 4a plus 3b minus 2b plus c minus c. And we know that the c will cancel out. So we have, if I subtract 8 from 15, then I'm going to get 7, which is equal to 9 minus 4a. 9a minus 4a gives me 5a, and then plus b. I can call this also equation 5. Good. Now, once I have equation 4 and equation 5, I can also solve the 2 simultaneously by subtracting equation 4 from equation 5. Okay, equation 5. Good. If that is the case, then I can write 7. I can write 7 minus 5, which is equal to 5a minus 3a plus b minus b. Since we have 1b here, 1b here, then the b will also cross out. Okay, having 2 is equal to 2a. Then I can divide both sides by 2. Okay, so I'll divide both sides by 2. This one goes, then I have a is equal to 1. So it means I have gotten one of the answers here. If I have this, I can also substitute if into any equation. So I can say put a is equal to 1 into equation. So let me put this into equation. Which of the equation I can put this into equation 4? To equation 4. All right, good. So for equation 4, this is equation 4, 3a plus b. So whatever I see my a, I'll put 1 there. This is equation 4. Okay, so I will then have 5 is equal to 3 to bracket this plus b, where I have 5 is equal to 3 plus b. If I group items or by transpose, then I'll get b is equal to 5 minus 3, where b gives me 2. So it means I have also gotten 2 for B. Okay, yes. So you solve it like this. It goes like that. Once we have 1 for A, 2 for B, then I can substitute A and B into any of the equations where we have C, so that we can get the answer for C. So I can put A is equal to 1 and B is equal to what? 2 into equation 1, because I have C there into equation 1. What is equation 1? Equation 1 is what? 3. Equation 1 is 3 is equal to A plus B plus C. So if I'm to substitute these values, then I'm going to have 3 is equal to 1 plus 2 plus C, where I have 3 is equal to 3 plus my C. Okay, in this case, I'm going to group like terms. So let me continue from here. So I'm going to get my C, which is equal to 3 minus 3. So by transpose, I'm going to get C is equal to what? 0. So it means that we have 0 for C. Once we are able to find the values of A, B, and C, we can just substitute these values into the general equation, which is given as y is equal to ax squared plus bx plus c. So I'm only going to substitute that. Then I'll have A, which is 1 multiplying x squared, plus B, which is 2 multiplying x multiplying x, plus what? C, which is 0. So we have 2 here. Then I can get y is equal to x squared plus 2x, and this is 0, which will go. This suggests that my rule for such quadratic mapping is y is equal to x squared plus 2x. This answers the equation. It's very long, right? No. If you understand what you are doing, this one becomes very easy. It's very easy. Okay, so when you get questions like this, that is how you should go about it. All right, so once again, this is your facilitator, Evans Okay, and this channel is Mazris TV. Don't forget to subscribe, like, and share the videos. Try your best to subscribe so that you get more videos anytime new videos are posted. So see you next time. Thank you. Bye bye.